domain and range and all of the function properties we're going to deal with. Okay? So for right now, I'm going to try and put it up. Okay, that's when we start. So domain, range, increasing, decreasing, positive, negative, max, and min. These are all of the ways that we can talk about functions, okay? Sometimes they'll give you domain, sometimes they'll give you increasing, sometimes they'll give you positive, sometimes they'll give you positive and range. They're just giving you components of stuff so you can kind of piece things together. Okay, let's break down what these things are. So first things first. Domain is essentially like your base format. This is the most important one. And that it basically is saying, where does everything exist in this function on the x-axis? So where does it exist on the x-axis? So I'm only describing where it exists in relation to that axis, left, right. Okay? And we always read left to right. We always start left to right when we're doing domain. The range is going to be dealing with the y-axis. And much like Drake popularized, we start from the bottom now. So you start from the bottom and go up. I'll see myself.
Please do.
So bottom up. Okay, so really you can just say like, that's how we read it. So you start at the floor, go to the ceiling. Okay? Now, the rest of these four right here, we talk about the domain of the piece of the function that is increasing. So this has a relationship, like domain is like reused for all four of these guys right here. And we'll go into it in more detail, but I prefer giving you like the full, broad strokes, what we're going to be encountering to start out with, and then we'll dive into them individually more so. So let's talk about increasing. So really all it's saying is an increasing, or where does it exist on the x-axis when increasing? That's all it's suggesting. So, for example, if I had something that looked like this guy here, and let's actually get into, a parabola, where is this guy increasing? Well, when I'm talking about increasing, it's the same rules that apply for domain. I'm always looking left to right. So think about if you were just a little dude, starting on the far left, you'd be walking downhill. So that's decreasing. Whereas from this point here, everything is uphill. Everything is increasing. So if this right here, where it starts to go up, is 3, then the increasing part of that function would just be 3 to infinity. So I write the domain of just the increasing part. Okay? And decreasing would be the same thing. Okay? Still x-axis, but when decreasing. So for example, this one would be negative infinity to 3. So what's important about it too is there's actually value in this. When we get into these guys later on, this is actually telling me a part of that function that's super important. It's telling me where it transitions to increasing. That's the axis of symmetry. I can use that later. Okay? The next guy here, positive. Okay? So this one's a little bit more different. Okay? And I'm going to use this guy here. Okay. What the heck does this mean? Positive is just suggesting, so you'll confuse. If you're going to confuse anything, it's going to be increasing, decreasing, and positive and negative. you'll interchange those. Positive basically tells me, where does this function exist above the x-axis? So where does it exist above the x-axis? So let's just say this guy starts at -1 and then 3, 1, 3, 4, 4, 7. Okay? So right now, we know in this instance right here that it sort of started at -infinity, it went to -1, and then because it dips below the x-axis there, I don't care about anything below the line. Where does it show up again? It shows up at x is 7 and goes off to infinity. So it's still talking about x-axis. So you can say it's still talking about the domain of anything above x-axis. Right? So on this example, you can say -infinity all the way to -1, including, put my union symbol, and it started back up at 7 and went to infinity.
Instead of saying anything above x-axis, can we say above like -1?
There's another, I mean, I would say I would keep to above the x-axis because it's basically just saying like that's the barrier. That's the like the floor of it. Because then I'm alternately also gonna say like the negative is me saying, tell me where it exists on the x-axis, okay, for anything below x-axis. So for that one's a lot easier to write out. I'm just gonna say -1 to 7. Because now, the negative part is literally just going to be looking at where does that piece exist. I don't care about anything above it. Okay? So that's it in a nutshell. Now, last but not least, these are rare, but they will also say it. Maximum, minimum. It's the max and the minimum in the function. But both of these relate to y-axis. So basically I might even just put it like, think about like the height. Okay, if you're looking at it, so like bottom up. So the max would be how high it goes, the min would be how low it goes. So for this specific guy here, what's the maximum of this guy?
Infinite.
So his maximum would be infinite, and his minimum would be whatever I decide to put right here. So let's just say -2. So the minimum would be -2. So that one's, there's no fancy notations. It's just like, it is what it is, it is what it is. Okay, but this is function properties in a nutshell. Domain is everything x-axis. It goes from left to right in terms of how I read it. Range goes from the bottom up, that deals with the y-axis, and then the increasing, decreasing are literally just where is the function going up, where is the function going down. We'll practice a bunch of these guys here. And then positive and negative is where is it above the x-axis, where is it below the x-axis. But this is function properties in a nutshell. No. You turn on.